Hi, I'm Sonam Adinolf, and welcome to my presentation on user preferences in game agent customization. Overall, the context for this study is to improve social connection in digital learning environments. Avatars are the digital representations of people in digital spaces. Agents are similar to avatars in that they are entities in a digital space. Agents are controlled by a computer. Even though agents are common, people prefer interacting with avatars. One potential venue to improve adoption of agents is to improve users' sense of connection or relatedness to the agent. Need for relatedness is centrally important to internalization and crucial in life well-being, so it's worth exploring its effects in the context of agents. We'll explore customization as a design feature since it has shown positive effects on motivation with avatars. So, our aim is to understand user preferences and interactions while customizing an on-screen agent in the context of a VR-based cybersecurity training scenario, with a cartoon-style robot agent partner. The research question is, what are satisfactory numbers of options when customizing an agent partner, both in terms of attributes and choices within each attribute? And does gender play a role? So, Study 1 was a pilot in-person lab study with 15 participants, 11 male, 4 female. Google's Androidify web app was used for the customization task. The app had 12 different attributes to choose from with varying numbers of choices within each attribute. We captured participants' eye gaze while they were customizing the agent's appearance, and we asked participants questions about how they felt about the number of attributes to customize, the number of choices within each attribute, and their enjoyment customizing each different attribute. Self-report survey asked participants to sort out which attributes were important to them. So, the findings were that the top and bottom clothing were the most preferred attributes to customize, and that participants actually spent most time looking at the choices rather than the agent itself. Based on some results from the first study, we iterated to an online large-scale study, recruiting participants via Amazon's Mechanical Turk. A 3x3 between-subject design was used, with Group 1 having the fewest number of attributes to customize and fewest choices, and it increases as you can see in the chart. So a custom application was developed with standardized numbers of choices per attribute. Participants rank-ordered the importance of the attributes. We asked about users' attitudes towards the number of attributes and number of choices within each attribute. We asked 3 questions about their preferences for different agent style, namely more cartoon-like, more realistic, or 3D. And lastly, they rated their enjoyment of customization process using the intrinsic motivation inventory. Here, the blue bars represent attitudes towards the number of attributes, and the red bars represent attitudes towards the number of choices. So as you can see, the satisfaction goes up as those number of choices and attributes go up. But looking closer at the data, we can also see that a small number of attributes can be made up for with a larger number of choices, and vice versa. Regarding the importance of attributes, in this case, hair actually came in top ranked across all groups, though top and bottom were still highly ranked by the participants. There was no difference in enjoyment between groups, but women did enjoy it more than men did. And regarding style, participants said that they prefer 3D. So combined, these results present designers with a rather flexible set of design options. They can present users with a few attributes to customize, but many choices in each. They can design many attributes with a relatively limited set of choices. And when we looked to see whether there was any sign of choice overload, we did not see a point at which, above which the user's satisfaction started to decrease. So this is a novel finding in choice literature, as well as choice overload, and extends those to digital environments. A limitation of both these studies is the agent being customized was in 2D. The next stage will be to see whether it transfers to 3D. That is the next step of this project and study. Also, we'll be possibly looking at different agent types, aside from robotic. In conclusion, this study provides the groundwork for the design of future research into agent customization. Having a better understanding on the lower bounds of acceptable customization levels will allow researchers to investigate psychological effects of such customization, as well as providing a new starting point for choice overload research in digital spaces. Thank you.